How do you get something dead flat when you don't have a machine shop in your back pocket? Here's the problem. I'm building these Gingery machine shop tools, which need to be precise, but I don't have them built yet in order to machine them to be precise. There is a way. It's extremely tedious, but I have found a lazier option to speed it up a bit. First up, why isn't it flat? The pattern was flat, right? Well, flatness is relative, and there are many opportunities for the casting to go out of flat. First up, I made the pattern out of wood. Ask any woodworker out there, wood moves. Moisture causes it to expand and contract. It does not expand perfectly evenly every time, so even if it was flat, give it a day, it won't be flat anymore. And even if you were to keep the moisture perfectly consistent through the whole time you're making it, the glue is full of water, so that'll just screw it all up. Even a perfect pattern will result in a non-perfectly flat casting. When you're ramming the pattern in the sand, all that force and the weight of the sand can bow them slightly. Removing the pattern can jostle the sand a tiny bit. Pouring in all the heavy metal can warp the sand just a little bit. Then when the thing cools off, it like shrinks. Most metals shrink anyway. When it's solidifying, and then as it's cooling, it shrinks. So it's basically hopeless. I mean, it came out pretty good. It came out pretty good. But to a machinist, pretty good is like horribly out of level. Remember, flatness is relative. And this lathe bed, it looked really good out of the sand. You know, it couldn't have been off by more than 1/16 of an inch over the whole 2 feet span of the thing. Laying a nice straight edge along the surface here told me a couple of things. One, it was highest in the middle, from about here to here. And two, one side was pretty much flat, almost, not quite, and the other side tapered off to nearly 1/16 of an inch at one of the corners. So to fix that problem, you basically take away all the high spots, you scrape those off, and you lower the high stuff, so the high stuff goes down to the low stuff, and if you do it right, it'll all end up at the same level, and you won't have introduced any warp or twist or bow or anything. So here's how that works. You're going to need a reference surface that you know is dead flat. I have a granite surface plate. These things are heavy. Preferably, you want one larger than the thing you're going to flatten. I don't, unfortunately. This bed's 2 feet long. This thing's 18 inches by 6 inches. I got this thing many years ago from Woodcraft, which is a woodworking tool supplier. I think they market it as a way to like check for flatness on the bottom of your planes. But in general, it seems like any of these surface plates that have at least one dimension that's 2 feet or longer, they're just insanely expensive. Now, it's been a while since I checked. If I find a big one that's cheap, I'll put a link down below. If not, I'll just link this one. This one is under $100. Some of the bigger ones are like $500 or $800. And that's a little out of budget. Now, the way the surface plate works, you take this little tube of Prussian blue non-drying dye, squeeze some on there, not a lot, and take a rubber wheel thingy and spread it out nice and even. You want it really, really thin. That's the thing, really thin, but spread it out throughout the whole thing. Then take the surface that you want to flatten, like that surface, set it down there and move it around. Now when you take a look at it, anything blue is a high spot. Scrape away the high spot, don't scrape away anything that's not blue, rinse and repeat. Eventually, it'll all be the same level. That's the goal anyway. What I found with this bed, interestingly enough, we have some dividers in there. They split it up into 4 big sections, and anytime there was a divider, there was a little bit of a low spot. Shrinkage, probably. My bad. It's not even cold out here. I don't have a good excuse. Anyways, the 2 outer segments were lower than the middle ones. This meant I could take the 2 middle segments, stick them on the surface plate, and move them back and forth. The whole length of it would be over the surface plate at some point, and I would be able to check the flatness of the edges relative to the flatness of the middle. As expected, the side segments, they never even touch the blue, not a bit. Now this is a lot of material to remove. It doesn't seem like a lot, because like I told you, less than 1/16 of an inch, but scrapers remove so little material. That makes them very precise, but also very slow. I need reckless and fast. Power scrapers do exist, but I don't have one. But I do have a grinder and a flap disc. Use a flap disc, especially with this metal, ZA12, probably aluminum too. Grinders gum up with the metal, and they stop working right away. Flap discs don't. Also, flap discs I think are a little less aggressive, and you're not trying to like dig gouges into the thing, because that'll just create new low spots that you will then have to lower the whole surface to. Be very careful. I'm using this is a 60 grit flap disc, and I probably should use an 80. You know, power tools are excellent at ruining your projects much faster, so be very careful. Now this took way longer than I thought. despite, all the noise and the zinc dust that just got all over everything, wear a respirator. Obviously, that's not good to breathe. But if I did all this with the scraper, I would still be doing this like 3 months from now, and my arms would probably fall off. So get one of those headphones, the Bluetooth noise canceling ones, put a podcast on your phone, and just rinse and repeat over and over again. Die, scrape away the blue, die, scrape away the blue. Eventually, you will get there. This probably took 2 or 3 hours of just the grinder step, and that was the rough flattening. Once you get it down to the point where you're getting blue splotches kind of evenly along the whole length, put the grinder away. And you will have splotches, kind of speckles and dots throughout the whole length. If you have like solid blue, like sometimes you might see solid blue, that means you put way too much of this on your surface plate, and the layer of dye is so thick on here that it's thicker than the surface variation on your part. Wipe it off, try again. Grab a machinist scraper. Gingery suggests you use like a wood chisel that you've sharpened. Now wood chisels are generally tool steel, and they're pretty hard. And they could work decently well on like aluminum, probably even on the zinc stuff, but don't. We have better options now. These scrapers I'm using, Chirpy made these. It's just a chunk of carbide. I think it's brazed to the end of a steel rod. Now he's not gonna make free scrapers for all you guys, so go to Amazon and just get a carbide scraper. I'll link one down below. It's long, you want a long one, and a removable head, so you can take it off and sharpen it, put it back on. Get this thing out my way. The way you use this is pretty simple. So you got this long thing, pretend this is all covered in blue, right? You kind of hold it at an angle. I hold it with this arm, and I push down with this, and you just kind of scrape away the blue. Pretty simple, right? Scrape away the blue. Don't scrape away anything that isn't blue. The higher angle you go, and the more you push, the more metal you remove. But really, it removed the zinc stuff pretty fast. You can get some of these that are like shorter and they're cheaper, or you can get ones that don't have a carbide tip, they have a hardened steel tip. Don't bother with those. Carbide's the way to go. At least that's what machinists tell me. This step actually didn't take that long. A lot shorter than the grinder. Now these take off a tiny, tiny, tiny bit of metal, but remember, I'm not flattening the top here. I'm just removing the little undulations from the grinder. Now when I was using the grinder, I wasn't like digging away. I was basically touching it with the flat surface of the corner there of the flaps, just so I didn't gouge anything too deeply. So I basically had a flat surface that was uneven. I wasn't scraping it flat, I was just removing the unevenness. And it probably took, I don't know, it took more than a few passes, let's be real. But it certainly didn't take me 3 hours, maybe 1 more hour of scraping. I ended up with a bunch of tiny, 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 tiny blue marks over the whole thing that were very difficult to see. It seems like the thinner it gets, the harder it is to see, and the more you scrape this, the higher the glare on this thing. This zinc stuff is really shiny. At some point, you're going to end up with a bunch of tiny little blue dots spread out evenly throughout the entire thing. That's probably good enough to stop for this part, because this is not a bearing surface. All we want here is a flat surface that's a base for the ways, which is made from a steel plate I got sitting over there. It's actually kind of hard to see the blue marks when you get to this point, because I'm making them so thin that they're not really dark, and this metal, since the whole surface has been scraped, it's really, really shiny. It's very, very reflective and glary. So I had 2 light settings that I could use. Too much glare that I can't see what I'm doing, or not enough light that I can't see what I'm doing. Good times. This is easily the most tedious thing I've done on a project. No, I think sanding Bondo was worse. Other than that, and the bed isn't even done yet. I have to install the ways. That's going to be another major deviation from the book. I'm pretty sure if you can make it through this stage, you're far more likely to finish the lathe than any other stuff of the process. My shoulders are killing me.